because I feel like third bell. I covered. Yeah. I got Legos for Christmas, so I built those. I got a snowman and a reindeer and okay. So here's our vocab then, some of the basic stuff. In your own words, write the meaning of the vocabulary term. Well, yeah, only I don't want it in your own words. I want it so it makes sense. A diagonal. If I ask you to draw a diagonal, all of you could. But explaining it, that's a whole nother thing. So first of all, in a triangle, there are no diagonals, right? You cannot draw a diagonal in a triangle. But in a four-sided figure or a five-sided figure, we could draw diagonals. So what are they? What's a diagonal? It's kind of a tricky one, isn't it? Okay, so somebody's showing me it's a line, and they're going, well, third bell, somebody said from corner to corner, and I said, well, so is this a diagonal? But that's corner to corner. Okay, you want opposite corners. That's not a bad way to say it. So I guess you mean something like that. That's an opposite corner. What's opposite this corner? Oh. So we have to be a little more specific. First of all, let's call corners vertices. So, any ideas? All right, so here's the technical definition then. We are going to connect non-consecutive vertices. So then if we go back and look at this original picture, this is a vertex, but those are consecutive vertices, so that won't work. But from here to here, that's non-consecutive, so that's a diagonal. And there's another diagonal we can draw in there too. And over here, we can draw quite a few diagonals, crisscrossing stuff. Okay, equilateral polygon. Well, first of all, poly means many. So even a triangle qualifies as a polygon up to a 100-sided figure or whatever. Some of them have names, some don't. But if it's equilateral, what does that mean about the polygon? So all sides are equal. And if it's equiangular, an equiangular polygon, all angles equal. But both of those don't have to happen at the same time. I can draw a four-sided figure where all the sides are equal, but the angles definitely are not. You can see that I have obtuse angles and acute angles, so the sides can be equal, but that doesn't make the angles equal. Or I can draw a four-sided figure where all the angles are equal, like a rectangle, but that doesn't make the sides equal. So if we want something where all the sides and all the angles are equal, that's when we call it a regular polygon. And I know the word regular seems like you're saying kind of boring, kind of plain. It's just a regular old day. But if you think about it, if I was talking about school days and it's just a regular school day, that means it's just like every other one. Everything's the same. Okay? So really, regular then means they're all the same. So in a quadrilateral, we would have four sides congruent and four angles congruent. And in a quadrilateral, there's a special name for something with four sides congruent and four angles congruent. It's a square. Yeah. Now, when we get to pentagons, hexagons, and stuff like that, we don't have any special names for those. We just have to call them regular pentagons, regular hexagons. So that's when we'll start using that word. Okay, so I said we had some formulas for today, and that's what we're going to look at is the angles in the polygons. So the sum of the measure of the interior angles of a convex n-gon. Convex, they just mean that it doesn't like dent in. And we looked at that a long time ago. We looked at convex figures and concave figures. So this one was concave, it dented in. We're only going to look at convex figures. And n-gon just means you can substitute any number you want. This is going to work no matter what amount of sides we have. Whether we have a decagon with 10 sides or a pentagon with 5 sides, the formula is going to work for all of those. So for this picture, we have 6 sides. Obviously, if we have 6 angles, we have 6 sides, right? So if we have 6 sides, we could plug 6 in there. So 6 minus 2 times 180. So 4 times 180. 180 and 180 is 360, and 360 times 2 is 720. So that means that for a hexagon, for a 6-sided figure, all of these angles should add up to 720. In this picture, you can see some of them are acute, some of them are obtuse, but no matter what, they have to add up to 720. And then a little while later, we'll look at a regular hexagon and check that out. Something that you definitely already know, quadrilateral has 360 degrees. You knew that before you came in here. Okay, so first theorem was about interior angles. Now we have a theorem about exterior angles. We've looked at exterior angles before. The sum of the measures of exterior angles of a convex polygon, one at each vertex. So again, they're being a little specific here. If I extended these sides in all directions, I'd get more than one angle here. That's why they're saying 1 at each vertex. So I just want to extend these sides. Kind of looks like a pinwheel when I do that, doesn't it? All the sides go the same basic direction. It's like I was kind of going to the right all the way around there. Well, it says for any polygon, if we look at one angle at each corner, they equal 360 total always, no matter how many sides it has. So it doesn't matter if it's a rectangle. If it's a rectangle, well, that one we can kind of think through that one. If the interior angles are 90, the exterior angles are going to be 90, aren't they? And there's 4 angles, and 9 times 4 is 36, so there's 360 of those. So that one we could actually figure the math out for. But here they're telling us that these exterior angles, those 5 of them equal 360. If I had a 6-sided figure, and I extended all of these sides, these 6 exterior angles equal 360. So that's actually a really easy formula, but sometimes a little tricky to think about. So all of those angles together equal 360. But you've watched me draw like a 4-sided figure, a 5, and a 6. As I keep drawing more and more sides, I keep getting more of these. Again, if I'm thinking about a pinwheel, eventually, if I could draw a bunch of sides, I'd wind up with, I don't know if I can draw a bunch of these, but I'd wind up just kind of going around in a circle. Basically, if I tried making a bunch of different sides here. And how many degrees are in a circle? 360. And so that's why those exterior angles, they basically form a circle around the figure. If I could draw more and more sides, we'd see that it just started looking more and more and more like a circle. Okay, so let's take a closer look at those two formulas. Those are on the front page, but I think you're going to find this page is more helpful. So we'll just go through and look at some of the basic polygons. So we'll start with a triangle. So triangle. Triangle has 3 sides. Next question seems kind of weird right now, but it'll make sense later. How many triangles? Obviously 1. And total degrees. Well, we already know in any triangle we have a total of 180 degrees. 4-sided figure. Just a general 4-sided figure is a quadrilateral. This whole chapter will look at specific quadrilaterals. So we'll look at squares, rectangles, rhombuses, kites, all kinds of things like that. Anything with 4 sides. But we're going to look just general quadrilateral first. Again, has 4 sides. Now, number of triangles. Well, that's where the diagonals come in. I want you to cut this into, using diagonals, cut it into really the minimum amount of triangles you can. So pick a corner, does not matter which vertex you use, connect it, draw the diagonals, connect it to the non-consecutive vertices. It's already connected there and there, so we'll connect it there. So we can cut it into 2 triangles. And each triangle has how many degrees in its 3 corners? Triangle has 180 degrees there. Here's another triangle. There are the 3 corners, another 180 degrees. So grand total, a quadrilateral has 360 degrees. And this is why I only wanted to use 1 diagonal, because I did not make any new angles. All the angle degrees are still in those same 4 corners. If I had drawn another diagonal this way, now I got a bunch of angles here in the center that I don't want. I only want to be looking at the 4 vertices, the 4 corners, and look at the degrees there. So that's why I want the minimum number of diagonals. Okay, 5-sided figure is called a pentagon. And this one doesn't look like the pentagon in DC. That one is a regular pentagon. This one is not. Regular pentagon in DC, all the sides of the building are the same length and all the angles are the same size. Again, pick a vertex, does not matter which one, and draw the diagonals from just that one vertex. So already connected there, we'll connect there and there. So I can cut this into a minimum of 3 triangles. Again, each triangle has a total of 180 degrees. So grand total, 180 times 3 is 540. I know, he definitely is, isn't he? Okay, and a 6-sided figure is called a hexagon. 6 has an X in it, hex has an X in it. Can you guess how many triangles we're going to cut this into? 4. Yeah, if we look at the pattern, we can see the next one should be 4, shouldn't it? Again, pick any vertex you want, connect it to all the non-consecutives, and sure enough, we've got 4 triangles. And 180 times 4 is 720. Okay. So now let's go back and take a look at that formula for a minute that we had. We had n minus 2 times 180. Well, we've been cutting all of these into triangles. So obviously the 180 degrees meant the 180 degrees in a triangle, didn't it? And look at the number of sides we had for each. N was the number of sides. And look at the number of triangles. For each number of sides, the number of triangles was related how? They were 2 less for each of them, weren't they? Because 2 of the vertices were already connected. We couldn't use those. We could only use the vertices that were not already connected, and so that was always 2 less. So that is where the n minus 2 part comes in. That's how many triangles you can cut it into. And you know triangles have 180 degrees, so you can multiply and find the total. So why know that? Why not just memorize the formula? Because it's going to be April, and all of a sudden you're going to be taking some standardized test and have to remember this formula. Right now, if I ask you for the quadratic formula, do you remember? Yeah, what? Exactly. So this way, even if you've forgotten the formula, you can still figure out how to get it, because you're still going to know there's 180 degrees in a triangle. I am confident that on the air test, if that were a question, you would not miss that one. I'm confident. So now we can rely on something basic that we already know, although it's helpful to memorize this formula, especially for this chapter. Okay, Now let's take a look at regular polygons. So this time, we want all the angles to be the same degrees. We want all the sides to be the same length. Regular polygons. But let's just focus on the angles again. We already said triangle has 180 degrees total. If all three angles are congruent, what can we do with that 180 to get the degrees of the angles? Yeah, so we can just take 180 divided by 3, and one angle is going to be 60 degrees. We knew that. But if we work out something we already know, and it works, then it kind of proves that what we're doing is right. So same thing with a square. We know a square has a total of 360 degrees. It has a total of 4 angles. So 360 divided by 4 is 90. So again, kind of makes sense. Again, any 5-sided figure has a total of 540 degrees. In a regular polygon, and I had to kind of draw this with words, so it's not perfect. In a regular polygon, all of these are congruent. So now I know I can just take 540 divided by 5 and get 108 degrees for each one of them. So every one of these then is 108 degrees. In a 6-sided figure, 720 degrees total divided by 6 angles, and so each of these then is 120 degrees in each corner. So that was the other, they didn't really give us this formula, but that's one that we can figure out then. So what it really is it's our original n minus 2 times 180, because that's the number we used here, divided by n. So that way we can find just one angle in a regular polygon. Now let's take a look at the measure of an exterior angle. Well, we already know the measures of the interior angles. The exterior angle is just this one here on the outside. Is there a relationship between those two angles? Made a straight line. They equal 180, right? So if we know an interior angle is 60, then 180 minus 60 is going to give us 120. So the exterior angle would be 120. But they gave us a formula on the front page. They said 360 divided by n. So if I did 360 divided by 3, well, that's still 120. So really, I have two different ways of doing this then. I can either say that one interior angle plus one exterior angle equals 180. We know that they make a straight line. That works. Or I can use the formula 360 divided by n. So in the next one, I can either say, well, if the interior angle is 90 degrees, the exterior angle has to be 90 degrees. Or I could take 360 divided by 4, and 360 divided by 4 is 90. Same thing here. I know an interior angle. I could find an exterior. 360 divided by 5. Well, 7 times 5 is 35. So 72 degrees. Oh yeah, and 108 and 72 is 180, isn't it? And 720 divided by, or sorry, 360. Sorry about that, I was looking at the other one. 360 divided by 6. Well, 36 divided by 6 is 60. And if an interior angle is 120, an exterior angle would be 60. So there's a couple different ways to do this. So in summary, the formula for the total degrees, and it didn't say interior. If it doesn't say, then it just implies interior, because that's usually all we're looking at. If they want the exterior angles, they will specifically say exterior. Otherwise, if it just says angles, it's the interior ones. So the total interior angles, n minus 2 times 180. Again, probably best to just memorize it. If we wanted to find just one angle in a regular polygon, we started with the total amount, n minus 2 times 180, and divided it by how many angles we have. Oh, and that's another thing to be careful of. N. n can be the number of sides, but n can also stand for the number of angles. And that should make sense. I mean, obviously, if it has 5 sides, it has 5 angles. But sometimes we get a little lost in the problems, and we kind of forget exactly what it is that they're asking us for. The number of sides and number of angles should be the same thing. Okay, total exterior degrees, 360. And that is a formula. However many angles you have, 5 angles total up to 360, 6 angles total up to 360. However many you have, the total of them is 360. If I want just one exterior angle, then I'm going to do 360 divided by n. And that also should say regular, because that's only going to happen in a regular polygon. Okay, so let's work through a few of the practice problems. I don't think we're going to do all of these. We'll just pick one of each. Reading, that's one of the things we have to be really careful of. First, we want the sum. Sometimes it might say just find one angle. Sometimes it might say find the sum. So make sure you know which kind of problem you're working. And interior angles or exterior angles. Again, be careful. So the sum of the measure of the interior angles of whatever polygon, that's the n minus 2 times 180. And an octagon has how many sides? 8. So all this is just a substitution for an algebra problem. 8 minus 2 is 6. 6 times 180. Well, 6 times 8 is 48. 1,080. So that is, look back at the question, that is the sum of the measures of the interior angles of an octagon, 180 or 1,080. Now, I really don't expect you to memorize these. That would be too tricky, and the quiz will probably have a 31-sided figure, so it won't do any good. So you really have to just know the formulas. Next section, find the sum of the measure of the interior angles of a polygon, I'm sorry, the sum of the measure is given. Find the number of sides. So they're saying this 900 is something minus 2 times 180. That n stands for the number of sides, so if I solve for n, I know how many sides it had. So, how am I going to solve for n? This is PEMDAS backwards. SADMAP, yeah. So what do I do first to solve for n? Divide by 180. So now it's going to say n minus 2 equals, let's see, 900 divided by 180 is 7. No, 5. I think it's 5, isn't it? 900 divided by 180. Yep, 5. Then, what do we need to do to find n? Add 2 to both sides. So n is 7. So a 7-sided figure has a total of 900 degrees. So sometimes they're going to tell you how many sides, you plug it into the formula. Sometimes they're going to give you the total degrees and ask you for the number of sides. Then you have to solve some algebra. Okay, the measure of one interior angle of a regular polygon is given. Classify the polygon by the number of sides. Well, if we look back at the formula for one interior angle, that is what we would have to set equal to that number. And with n in 2 different places here, I might have a few students that maybe if you're in Algebra 2, you might be able to solve that. That's kind of tricky. So there's actually an easier way around that, because the number of interior degrees changes for every single shape, but the number of exterior degrees doesn't. There's always 360 degrees around the outside. So maybe it's not the interior degrees we want. I mean, I don't know how many sides this thing has, but if it has 156 degrees inside, couldn't I figure out how many it has outside? Yeah. So if it's got 156 degrees inside, then the exterior angle must be 24, right? And if the exterior degrees always equal 360, but I don't know how many sides there are, but I know it needs to equal 24. So how would I solve for n there? Think about a really easy math problem. 8 divided by something is 4. So in your head, didn't you do 8 divided by 4 is 2? Yeah. So we could do the same thing here. 360 divided by something is 24. So 360 divided by 24 is something. And 360 divided by 24 is 15. So that means this had 15 sides and 15 angles. And if you're not sure, you could go right back up here and plug 15 in and work it out and divide it, and guess what? You'd come back up with a 156. So be careful. That's just kind of a trick problem. When they only give you one interior angle, it's almost impossible to solve. But you can always solve if you have one exterior angle. And then we have these random non-regular polygons. In these, notice there's only one missing angle. That's really all they can do. Because if all the angles aren't equal, then you have to know all but one. So the key here is the number of sides. This one has 4 sides. So a 4-sided figure should total up to how much? Should have 360 degrees for the angles. We've got 3 out of 4 of the angles, so we can do that. We can add these together. So 45 and 65 is 110. So 205. So 360 minus 205 is 155. And that was an obtuse angle, so that kind of makes sense then that that was 155 degrees. Over here, 1, 2, 3, 4, 5, 6 sides. So if it has 6 sides, we already worked that one out. 6 sides has how many degrees? 720. So we know we've got 720 total. We've got 90, and if I were you, I'd label that. 90 plus 120 plus 130 plus 140 plus 150. And if we work all of that out, that is a grand total of 630. So that means we have 90 degrees left. And little x there definitely looks like that could have been a right angle. Number 11, again, has 5 sides. So the degrees in a 5-sided figure were supposed to total up to 540. We did that one on the front. Now this one, they did leave 2 of them blank, but they said they were both the same size. Otherwise, they couldn't do that. They couldn't leave an obtuse and acute angle blank. We couldn't figure out what that is. So I've got 90 plus 70 is 160, 260. So 540 minus 260 is 280. And again, those are both equal, so divide by 2. So each angle is 140 degrees. And yeah, they look obtuse, so it should work. Here, I don't care how many sides there are, because what kind of angles did they give me? Exterior angles. And exterior angles always total to 360. Except now I have a little algebra problem, don't I? So 4x plus 98 plus 162 equals 360. So 5x plus 260 equals 360. If 5x equals 100, then x is 20. Okay, so you have to know which formula to use. You have to watch and see how those are worded. And with something like this, then, you need to know what the total is for those pictures on the bottom. All right, so homework. We have some problems to work there. And then on block day, I'll be